This is really a two-part lesson, with yesterday being the first part and today being the second part. And the second part of this is going to be creating exponential equations. So we want to understand that when we have an exponential equation, we're going to have y equals a times some base raised to variable exponent. And we're going to say a is equal to the initial amount. And we're going to say that b is we'll say it's the growth slash decay value. By what factor are you growing, or by what factor are you decaying? Now remember, for growth, your base has to be greater than 1, and for decay, your base is between 0 and 1. Remember what we said yesterday, your base cannot be 0, and your base has to be greater than 0. Okay, so that we have to understand. And we also know that b cannot also not equal 1. Okay, because 0 to the power of anything is 0, 1 to the power of anything is just 1. So they don't really grow or they don't decay, so they're not really useful. So we need to determine what the value for A is going to be and what the value for B is going to be. So A is normally discovered whenever x is 0. So your initial amount is when time is equal to 0. So this is going to be our A value. So here A is going to equal 4. Now, as we look from 4 goes to 2, what's this doing? Is it getting bigger or getting smaller? It appears to be getting smaller. And by what factor is it decreasing? Okay, so we want to find the base now. We want to find the rate of change, basically, or the amount that it's changing. So normally we do reverse division. So I'm going to say 1/4 divide 1/2. I'm going to say how much does that equal? Then I'll do 1/2 divide 1. How much does that equal? 1 divide 2, and then 2 divide 4. Now it's easier when you see these numbers. The rate of growth is going to be 1/2. The rate of growth here is going to be 1/2, and then this is 1/2, and 2 over 4 is equal to 1/2. So we can see by reverse division that we're getting our B value here to be 1/2. So we're getting ready to write the answer, but I just need to pause. So I'll write my answer at the bottom of the paper since it's getting a little jumped up here, and I will say example 7 is equal to A times B to the X, which is equal to, well, A was 4, the B, always put it in parentheses, and then raise it to the X. So that would give you, now let's see what happens if we put that in our calculator. So we go to our calculator, we say, okay, we think it is 4 times 1 divided 2 raised to X. And we go look at the table. So we hit second bracket. And we can see 0, 4, 1, 2, 2, 1, 3.5, 4, 0.25. So it's exactly the same table, so I must have the right equation. So that's a good way to check it. Okay, so the next one we're going to do is example 8. Pause it if you don't have this already, but I'm going to do some erasing here. Maybe I should put these on different screens, so hold on, I'm going to pause this and take a couple pictures. Okay, I think I have it set up now, so let's go to the next screen, and we're going to do example 8. So basically in example 8, we're missing 0, but we probably have enough data to where we can see what's going on here. It appears that when I go from 14 to 28, I'm timesing by 2. When I go from 28 to 56, I'm timesing by 2. And then 56 to 112 means I'm timesing by 2. And then 112 to 224 appears I'm timesing by 2. So it appears to me that B is 2 here, right? So if B is equal to 2 here, what times 2 would give me 14? So probably we're going to end up with, like, let's say a 0 and a 7. So when I think about it now, this is probably going to be my value for A. Now, if I do that reverse division thing, 224 divided by 112 is equal to 112 divided by 56, which is equal to 56, which is divided by 28, which is equal to 28 divided by 14, which is equal to 2. So you can see that my base here is 2. So of the form y equals a times b to the x, I'm going to say y is equal to 7 times 2 raised to the x power. So always put your base in parentheses. If you want to check your answer, you can say fine, go to your y equals, and you can put in 7, and then you can go 2 to the x, and you can hit second graph, and you can look at your table, 114, 228, 6, 4, 112, 5, 4, and it appears we have the right graphs. We've just checked our answer. So I want you to do example 9 and example 10, give them a shot, and pause your screen, and we will work them out in a minute. Okay, so for example 9, I can see here that A is clearly in this position because x is 0, A must be equal to 3. And then I can also see that I can do 15 divided by 3 should equal 75 divided by 15, which would equal 375 divided by 75, which is equal to 1875 divided by 375, which is equal to 5, which is then equal to B. So therefore, if I'm going to write it over the form y equals a times b to the x, then this should equal 3 times 5 to the x. And I can go to my calculator. And I can put in 3 and then 5 and then hit set graph. I can look at my table and see that my table matches quite nicely. Pause if you need to. I'm going to the next screen. So for example 10 here, we have some numbers. So calculator time, I'm going to say fine. I'm going to say 10.125 divided by 6.75. Then we'll say 6.75 divided by 4.5. And then I can say 4.5 divided by 3. Then I can say 3 divided by 2. And 3 divided by 2 sort of tells us, you know, so our base here is going to equal 3 divided by 2, because that's equal to 1.5, correct? And this is 0, so A is equal to, so therefore y equals a times b to the x should equal, let's say y equals 2 times 3 halves raised to the x. Now, if you say it's equal to, y is equal to 2 times 1.5 raised to the x, that's probably decimals will probably give you, I don't know if fractions will give you a fraction in your table or not, so let's investigate. So let's say, okay, this is 2, and then, I'll clear that. Let's say it's 2 parentheses, and we'll put a fraction in here. See what happens. 3 on top, 2 on bottom. I need to close that and erase it to the X. So now when I hit the second graph and look at my table, see, it's not in decimals like my original table was. So I can say, okay, fine, I can clear that and say 2 parentheses 1.5 raised to the X, and then I can hit second graph, and lo and behold, it looks like the table I was given. Okay, so pause if you need to, I'm going to the next one. So now what if A is not easy to find? You're given stuff that probably does not divide evenly across. At this point, we're going to go through some steps here. Basically, I'm going to have these steps printed out for you so you'll be able to see them and you'll just follow along as I go through. So the steps for exponential regression, we are going to use our stat editor. So let's sort of read these steps and then sort of go to where we would be in the screen to see this stuff. So it says put X values in list 1 and Y values in list 2. Well, you've probably done this in a prior math class, but I'm going to reset my calculator. So let's see if I can make this a little smaller here. Okay, there we go. Let's do that. So now you have a stat button, which allows you to edit. So you hit enter. It says put X values in list 1. So we're going to hit stat enter. That's where I have those words in red there. View and so stat enter. So your X values are going to go in list 1 and your Y values are going to go in list 2. So let's do that. So let's say find. And let's make this a little smaller where I can have both on my screen. So I'm going to say, okay, so X's are 6, 7, 8, and 9. And then right arrow, and then 22.781, and then 34.172, and then 51.258, and then 76.887. So we have our data in our calculator. Let's go through the next step. Okay, it says turn your plots on and zoom stat. So you want to see if indeed it's exponential looking. Does it have a slight curve to it? Does it look like an exponential graph? So the easiest way to turn your plots on is hit second y equals and enter and just turn them on. Now it's already set up for a scatter plot, so you don't have to do anything else. So as soon as you turn your plots on, you can hit zoom. Stat is zoom 9. So zoom stat is zoom 9. And it can appear that it has a slight curve to it. It appears to be exponential. So we are going to, since it looks exponential, we're going to do exponential regression, which is by hitting a stat right 0. So that's going to be the button that we hit. So if we hit stat and we go right and we hit 0, it's going to give us exponential regression. So exponential regression will look of the y equals a times b to the x form. So list 1 is where it's at. List 2 is where, okay, list 1 is where x is at. List 2 is where y is at. We do nothing to frequency. And we're going to store the regression equation in y1. Now the easiest way to bring up y1 is to hit alpha and the trace button. So to get y1, you want to hit alpha trace and then hit enter. Alpha trace enter. And we stored it in y1. Now we can calculate. So we've calculated. So basically our equation now for this value is A is basically 2. So A is basically 2 and B is basically 1.5. And we can raise it to the x. So the exponential regression equation was given to us by our calculator. Hit graph. And you can see since we stored it in Y1, that's drawing the graph into your picture. So because we did that store regression equation in Y1, guess where it went to? That big, long, ugly equation went into Y1 and we didn't have to type anything. So that step right there, step number 4, is very handy. Okay. So I've done everything I've had to do. So I've answered question number 11. Okay. So now we're going to practice a little bit of this. What if you're given 2 points? Well, hold on the practice on the calculator stuff. We'll do it in just a second. So I know that this right here is 0, so that means this here is A. So this is y equals 3, and then the base raised to the x. So this is an x and this is a y. So now I can say that 8 is equal to 3 times the base to the 4th, and then I can solve for the, I gotta pause it just a second. Now we need to solve for b. So the first thing I need to do is divide by 3 and say that's equal to b to the 4th. Now I can raise both sides to the 1/4 power. So then b would equal 8/3 to the 1/4. Now, in my calculator, I can say parentheses 8 divide 3 raised to the 1/4. 1 divide 4. It's going to give me some type of decimal. Okay, so if I keep 3 or 4 decimal places, then this should be y is equal to 3 was A, and parentheses 1.278 raised to the x. So now I have my equation, even though I was only given 2 points. Now keep in mind, the reason I know that's A is because if you say that 3 is equal to A times B to the 0, then B to the 0 makes 1, doesn't it? So then 3 is equal to A by default. So keep that in mind. Now, you try exercise 13 and I'll give you a minute. Okay, so we can see here that y equals A times B to the x, and if we say 4 is equal to A times B to the 0, A will equal 4. And then we know that y is equal to 4 times B to the x, and we can say 5 is equal to 4 times B to the 8th. Means we can solve for b, and we can say that 5 over 4 is equal to b to the 8th, and then we can raise both sides to the 1/8 power, and we end up saying that b is equal to 5 over 4 to the 1/8. We could use the calculator and say, okay, 5 divide 4 raised to the 1/8, and that's going to give me 1.028. Fine. So my final answer here should be y is equal to 4 parentheses 1.028 raised to the x. And my exponential equation. Pause if you need to and go on the next group. So now let's say in this case they did not give us the y-intercept. We would just then use the calculator and put 2 points in. But 2 points is really not enough, so this is really sort of a dangerous move. So if I want to reset my calculator, it's going to be the best for me. So to reset your calculator, you do second plus 7, 1, 2, enter. So we go stat, enter. So we're going to put a -1 in for x and a 2 in for x. And then the y's would be 3 and 0.75. So I have my data in my calculator. And again, I'm following those steps, right? I'm following these steps right here. So I put them in. There's really no reason to turn your plots on and look at 2 points. You won't be able to see a curve or anything. So you just go to do the regression equation by doing stat right 0. And then you come down to store regression equation and you hit alpha trace, store it in Y1, and you hit calculate. And that's your value for your answer. So this would be go to problem. This would be y equals a times b to the x would be y equal to 1 point, let's just say it's 8, 8, 9. Okay, so y is equal to 1.889. You could even say that could be 890. And then parentheses 0.630 raised to the x. Okay, you can practice that one, give that one a shot. That one, looks like we might have done that one before, just it was in a larger table. Those numbers look familiar. But if you see that it appears that if I say 28 times 4 makes 112, so chances are you could have another point here. You could say that it's 356, right? So you probably have enough there to actually go backwards and say that's going to be what 14, and then you're going to say, well, that would have been 07, and recognizing this problem was one of the ones that we had before. So putting this in the calculator, we could say stat enter, and we're going to put in 222 enter, 4 enter, and then 28 enter, and 1.2 enter, and then do stat right 0 and store the regression equation, alpha trace enter, and it gives us 7 and 2. And if you realize that was the problem from before, that was number 8, wasn't it? I think it was number 8, and sure enough, A was 7 and B was 2. If you recall, they just at the end gave us a couple points, didn't they? They gave us this one and this one. We still got the same answer. That's pretty nice. Okay, so for the last problem, I'm going to do, we're given a picture. So we're given a picture and they want us to find K given the graph. Okay, so we sort of have to know some things here. When I'm looking at this, I can see clearly they gave me this point, which was an X, and this was a Y. And clearly in the equation, there is a X and there is a Y. And if I plug those in, I should be able to solve for K. So I'm going to say Y equals K times 1/2 raised to the x is going to be 16 is equal to k times 1/2 raised to the, what, -2. So basically, I can say fine. I can say 1/2, and I'm going to raise that to the -2, and it gives me 4. So 16 is equal to 4k, therefore k should equal 4. And that's in the notes for today.